Everyone, today we are going to learn about dilutions. So, dilutions are basically when you water something down. So you take something with a high concentration, that's what we have here, and if you add water to it, right, you make it less concentrated, and that's what we have over here. So we're going to use this formula, M1V1 equals M2V2. And this is really useful in chemistry, especially for me when I'm making solutions. I generally make them really low concentration for our lab, but we usually buy high concentrated stuff and we dilute it, and that makes it last a really long time. Okay, so we're going to use this formula. M, of course, stands for concentration in moles over liters. V is volume. Okay, so let's take a look at this first example. How much concentrated 12 molar hydrochloric acid, so right away we got M1, we don't know the volume, okay, is needed to prepare 100 milliliters, so I've got V2, and of a 2.0 molar solution, so I've also got my second concentration here. So great, they give us all the numbers we need. All we have to do now is plug in these numbers. So M1 is 12 molar times V1 is equal to 2 molar times 100 milliliters. I'm going to divide both sides by 12M. And I get a volume of about 16.7 milliliters. Okay, so again, we're taking this small amount of very concentrated acid, and we're diluting it to a much lower concentration by basically adding water to it. Okay. Next, let's try to solve for another variable. If we have what volume should 25 milliliters of 15 molar nitric acid, so I've got M1 is 15M, V1 is 25 milliliters, and I'm trying to figure out the volume in this case. In order to prepare a 3.0 molar solution. Okay. So very similar to the last problem, we're just going to plug in those numbers to our equation here. M1 is 15M times 25 equal to 3M times V2. Okay, so we're going to divide both sides here by 3M. I get 125 milliliters. Okay, so again, whenever we dilute something, we generally increase the volume by adding water, and that'll lower the concentration. So this is what, like an inverse relationship. This is kind of similar to those Boyle's law problems that we did. All right, the last problem here is a little more complicated. How much water should be added to 50 milliliters of 12 molar hydrochloric acid to produce a 4 molar solution? So the hint here helps us out. First we got to find V2, and then we're going to figure out how much water should be added to our original solution. Okay, so we're given M1 and V1, 12 molars, 50 milliliters. M2 is going to be 4 molar. We don't know our second volume. So let's do this first. We'll solve it just like we solved the other problems using this equation. So 12 times 50 milliliters, 4 times V2. To get V2 by itself, we're going to divide by 4 molar. And that gives us, let's see, 3 times 50 is 150 milliliters. So that's not our final answer. Excuse me. The question is asking how much water should be added to our original solution. So if I'm trying to hit 150 milliliters and I start with 50 milliliters, right? And I'm trying to get to 150, the answer is I have to add 100 milliliters of water. Okay, and by adding 100 milliliters of water to my original solution, I will have diluted it to this 4 molar concentration, which is what I want. I'm going from a high concentration to a lower one, again, by adding 100 milliliters of water here. All right, make sure you do the 3 practice problems on your own, and have a good weekend.